Greetings, this is Scott. We're in Chapter 2 review of fractions right now. And in the first section, 2-1, which begins on page 61, there is a review of multiples and factors. You might go, why do we need to know those two things right now? It's because that's going to help us as we go forward in reducing fractions and even adding fractions, multiplying fractions, everything else like that. So when you're looking at a couple different things here, first of all, as you're looking at multiples, a multiple, if we had a number like 3, multiples of 3 are 3, 6, 9, 12, 15, and so on. Because it's what you get when you take 3 times 1, is 3, 3 times 2 is 6, 3 times 3 is 9, and so on. That's how you get your multiples. The other thing that's going to talk about numbers is factors of numbers. And the factors of numbers, that's all the numbers that are possible that you can multiply together to get that number. For example, if we're going to take a look at 3 again, the only numbers we can multiply to get 3 are 1 times 3. That is the factors of 3. But if we had a number, let's say like 24, we could take 1 times 24, or 2 times 12, or 3 times 8, or 4 times 6. All of those numbers are factors of 24. And like I said, this is going to become important as we go forward when we look to add and subtract fractions with all that. Another piece too that this leads into on page 64 is the difference between prime numbers and composite numbers. A prime number is a number that you can only get that number by taking 1 times that number. Okay? For example, as we looked at the number 3 here, 3 is a prime number because the only factors of 3 are 1 and 3. 24 is a composite number because there are more than just those two factors, 1 and itself, with the number 24. So you can kind of go through some of those things to look at prime numbers and composite numbers, and that will help you as you try and work with fractions that way. Some of the things that they will talk about then and things that you will hear are the least common multiple and the greatest common factor. If we were to take the number 4, and we'll look at multiples of 4 along with that too. That would be 4, 8, 12, 16. Okay, as we looked at this, 3 and 4, our least common multiple here is 12. Okay, common multiple, it's a multiple of each number. The least one is the one that's the least in amount, so that would be 12. That would be our least common multiple, or LCM. Now, when we look at factors, we can look at our greatest common factor, and if we used our numbers 3 and 24, our greatest common factor here is going to be 3. It's the largest number that goes into both 3 and 24. It is going to be 3. Okay? So, those are a couple other things that it talks about there, and like I said, those are going to become more important as you work to find the common denominator so you can add and subtract fractions as we go forward with that. As you look at some other things in this chapter, some of the things that they're going to want to do, I'm going to add another page here real quick, folks, so we can talk about some of these things. Some of the things they're going to talk about is they're going to ask about tests for divisibility. Oops. All right. Sorry. Oops. So in other words, how can you figure out if a number goes into another number? Some of them are pretty easy. For example, to test to see if a number is divisible by 2, you know it's an even number. That way you know it is divisible by 2. If you're looking to see if a number is divisible by 3, what you do is you add up all the digits in that number and see if that number is divisible by 3, then the entire number would be divisible by 3. For example, if we had a number, let's say 2,400, and 36. Okay, I take 2 plus 4 plus 3 plus 6. And when I do that, I get 6, 8, 15. Is 15 divisible by 3? Yes. So we know that this number here is divisible by 3. But that's what you can do for 3. For the number 4, okay, obviously it's going to have to be even because 2 was even there. But what you can do is you can look at the last 2 digits of a number, and if that is divisible by 4, then that number is divisible by 4. Using our same number, 2,436, is 36 divisible by 4? Why, yes, it is. You get an answer of 9. So that you know that this number is divisible by 4. 5, of course, is a pretty easy one. That number has to end in 5 or 0 to be divisible by 5. Now, another unique one is the number 6. For that one to be divisible, for a number to be divisible by the number 6, it has to be divisible by 2 and divisible by 3. So you can use those 2 tests there. So you can use those tests to see if it's divisible by 2. By 2 and by 4. Excuse me, not 2 and by 4. I have an eraser here too. I'm going to use that here. 2 and by 3. So in this case, we knew 2,436 was divisible by 2. It is divisible by 3. So we know that it is divisible by 6. Okay? 7, you're just going to have to divide that one out to know if it works. There's nothing you can do with that. Number 8, what you do there is you look at the last 3 numbers. And if that is divisible by 8, then the entire thing is divisible by 8. So for example, 430, we'll use our same number, 2,436. So is 436 divided by 8, does that come out evenly? Well, let's try it out here. I don't have my calculator handy, so we'll divide it out. 8 goes into 40, 8 goes into 43, 5 times. 5 times 8 is 40, 36. Nope, it does not go in there. It goes in there 4 times for 32 with a remainder of 4. So this number here, 2,000, is not divisible by 8. Same thing you can do here with to find out if it's divisible by 9. You can go ahead and add up all the digits. So once again, we did just like we did up there, 2 plus 4 plus 3 plus 6. That equals to 15. 15 is not divisible by 9. That does not work. So this would be the way you could tell if it's divisible by 9. And of course, if it's divisible by 10, it ends in a 0 with some of those things too. So one other thing I want to show you here in this section, let me insert another page here. At least that's our plan. We'll go back to our tools here. The other thing it talks about here too is prime factorization. And by what it means by prime factorization, right there. What it means by prime factorization, if we took the number 24, basically we want to get a number down to all the prime numbers that multiplied to get together to be that number. So for example, if we take that number 24 again, we could say, well, that is 2 times 12. Okay? Factor that down some more. We could say that is 2 times, and we know 12 is 2 times 6. And then we could have 2 times 2 times 2 times 3. And that's how you would go ahead and show your prime factorization for a number. And I believe it asks you to do that in the exercises for that. So I wanted to make sure I covered that. A couple other things it's asking you to find the least common multiple. I don't see it anywhere where it's asking to find the greatest common factor. Oh, I lied. I found that now too. But let's just take a look at a couple of those here too. Question number 84. It says, find the least common multiple. Actually, we'll do 84. Okay, so if we have 2, the multiples of 2 are 2, 4, 6, 8, 10. And the multiples of 3 are 3, 6, 9, 12. So as you're looking at this, your least common multiple, the smallest number they have in common is 6. So as you're working with your fractions, everything else like that, you're gonna make sure that that is your denominator. Numerator is top number, the bottom number is called the denominator with that. The other thing too, as you take a look at that, it's also going to ask you to find the greatest common factor of some numbers, and so we'll take like 18. There's 1 times 18, 2 times 9, 3 times 6. 4 and 5 are a no-go that way. And then if we looked at 24, we had 1, 24, 2, 12, 3, 8, 4, 6, and then 5, 5. As we take a look at these now, their greatest common factor, the greatest number they have in common, is 6. So if we were to reduce them down to proper fractions, from improper fractions, we could divide each side by 6, and then we would be all set with that. So that's a little bit on prime factorization. Also with the greatest common factor and the least common multiple with some of those pieces too. So there is some other different pieces on measurement and everything. I think we'll cover that as we get towards that a little bit more. But I think this will keep you busy here for that first section. Once again, please remember there are no homework assignments graded. It's just done to make sure that you know exactly what's going on and where we're at with some of those things too. So that's kind of where we're at with all that. Trying to think here. As we take a look at some different things in Unit 2. Have a great rest of the day, and if you do have any questions, please make sure you ask. Thank you.